video is about free body diagrams in physics. What are free body diagrams? Free body diagrams show all the forces acting on an object. The forces are represented as vectors, which convey magnitude and direction. The object is represented as a point or as a box. So, both of these drawings here are equivalent and acceptable. There are 4 steps you can use to draw free body diagrams. Step 1. Pick a system and draw it without its environment. Step 2. Draw all of the forces acting on the system. Step 3. Pick a coordinate system. Usually one axis is positive in the direction of acceleration. And step 4. Redraw the free body diagram with all forces resolved into components. Let's go through an example. An iron bolt hangs from a string. The top end of the string is fixed. Without touching it, a magnet attracts the bolt so that it remains stationary but is displaced horizontally to the right from the previously vertical line of the string. The magnet is located to the right of the bolt and on the same vertical level as the bolt in the final configuration. Draw a free body diagram of the bolt. First, here is the drawing of the situation explained here, and we at Study Buddy for STEM recommend that you make these little drawings once you read a problem, because it helps visualize what is going on and helps map out the forces acting on our system. First, let's do step 1. Step 1 is to pick a system and draw it without its environment. Our system here is an iron bolt, which we can represent with a dot or as a box. Step 2 is to draw all of the forces acting on the system. We can use our drawing to map out where the force of tension needs to go, because it is going to point away from the object and in the direction of our string. The other 2 forces we have are Fm, the force exerted by the magnet, and Fg, which is the gravitational force. Step 3 is to pick a coordinate system, and we are going to have our positive x-axis in the direction of the force of the magnet, which makes sense because that's the direction in which the iron bolt is displaced. Our last step is to redraw the free body diagram with all of the forces resolved into components. We do not need to resolve into components any forces that are right along the axes, so we don't need to touch Fm or Fg. However, Ft does have an x and y component, which we would represent like so. And once you do this, you need to erase the resultant force from the free body diagram, because now it is resolved into its components. Now, if this free body diagram were a precursor to some calculation questions, which it usually is, what you'll most likely need to do in addition to your diagram is to write the force components in terms of its resultant force. So here, we would want to express Ftx and Fty in terms of Ft. So for that, we're going to look at our drawing and notice that Ftx is opposite to angle theta and Fty is adjacent to angle theta. And so we would say that Ftx is equal to Ft sine theta and Fty is equal to Ft cosine of theta. That's all for this video. Thank you for watching and good luck studying!